Hi, welcome to the help video for your homework. Let's give you some help with question A then. So we need to determine the force which is applied to the ship in order to stop it. Now we need to use the equation force is equal to mass times acceleration. We know the mass of the ship already, it's given in the question, but we need to work out what the acceleration is. You need to do that. Okay. First determine what the displacement of the ship is as it's coming to a halt. In other words, how long it takes to halt. It's 13 kilometers. What's the initial speed of the supertanker? Oh, its cruising speed is 50 kilometers per hour. Okay. What's its final speed as it comes to a halt? I'll leave that to you. Its acceleration is something you want to find out, and we don't know how long the ship takes to halt. So you need to go to your notes and choose a Suvat equation which doesn't have t in it. You need to rearrange that Suvat equation to get acceleration on one side of the equation, and then work out the acceleration. Substitute the acceleration into this expression here, and you'll be able to work out the stopping force on the ship. Good. Let's give you some help with question B. Question B was a difficult question. I said it for my own amusement. So a person is in an elevator weighing a cheeseburger with a kitchen scale. You need to draw a free body force diagram showing the forces acting on the cheeseburger. So here's our cheeseburger. Little letters in the middle. Now one of the forces is obviously its weight. There's another force acting on the cheeseburger, and it's the reaction force on the cheeseburger from the kitchen scale, because the burger's sitting on a kitchen scale. Now usually, when something is stationary, the reaction force is equal to the weight. However, this cheeseburger is accelerating in a lift. The reaction force is going to be either bigger or smaller than the weight. So either draw a bigger arrow than the weight on the cheeseburger, or draw a smaller arrow. It's up to you. You might like to look at some of the information in the question to help you. Question 2, determine the weight of the cheeseburger. Well, you're not getting any help with that. Question 3, determine the magnitude and direction of the net force on the cheeseburger. Well, just go to your free body diagram, which you drew in part 1, okay, and put the numbers on the arrows. Here's one number I'm going to give you. The number next to the weight arrow should be whatever you worked out in part 2 of this question. Question 4, determine the magnitude and direction of the elevator's acceleration. You might choose this equation here. I mean, you've worked out the average force in the cheeseburger. You know the mass of the cheeseburger, and so you can work out the acceleration of the cheeseburger. Now, the cheeseburger should be accelerating with the same acceleration as the lift, because it's being held by a person within the lift. Question 5. At the time the person in the lift is weighing the cheeseburger, the American lift's instantaneous velocity is upward. Is the speed of the elevator increasing, decreasing, or remaining constant at the moment? So in part 4 you've worked out how big the acceleration is and in which direction the acceleration is. And in part 5 you're told that the lift's velocity is upward. So thinking about the direction of the acceleration, is it going to be decreasing or increasing the velocity? Or even making the velocity remain constant? That's all the help you're going to get. Good luck.